All right, Honors Physics, welcome back again. As you can see, it's pretty much the same deal as yesterday because I'm recording these both in the same day. Yep. Okay, so yesterday we looked at Castle Unit 3, Activity 5, and the day before that we did Activity 4. So what we have covered recently is that adding light bulbs in series with each other, that is one after the other in the same loop, kind of like these two are here, they're going to be in the same loop, that increases the resistance of our circuit. So it makes it harder for the charge to move when we add multiple bulbs one after the other in series or in a single loop. And then what we saw yesterday was that if we add them in parallel with each other or in separate branches, okay, so we would have another one kind of hooked up on either side of this. Having them in parallel actually decreases the resistance because essentially adding them in series makes it so that that charge has to go through more than one bulb. It has to keep pushing through each subsequent bulb. But then adding them in parallel gives the charge an opportunity to move around in a circle through the next one. So it basically has the effect of doubling the width of the wire by adding a second wire, okay, which is why it decreases the resistance to add them in parallel. And so what we're going to look at today is whether or not adding wires in series or in parallel affects the overall resistance of a circuit. We're going to start out by adding a wire in series. So we're basically just going to make this whole circuit have one more wire. Will that do anything? Make your prediction for that. Is that going to change the amount that the compass deflects from circuit A to B? Go ahead and make that prediction. And then the second thing that we're going to do is we're going to just take this wire here, and instead of adding it in series with this wire, basically making it just a double long wire, we're actually going to put that wire around this bulb here in parallel with it, giving that charge a different path that it could possibly flow through. So what is that going to do to our overall charge flow through the battery, and what's it going to do to the brightness of that bulb? Okay, so that should cover most of those prediction questions. Go ahead and write your predictions to those questions. Pause the video if you need to, and then I will resume in a moment here so that we can see our observations. Okay. As we can see, just so that we have a baseline here, here's our circuit as is. We see, since these are the long bulbs, they are not particularly bright. And we don't see a whole lot of deflection here either. Almost 20 degrees is the deflection that I'm seeing here. Almost 20 degrees. And if I disconnect this here, I think I'm probably going to have to set my phone down. Okay, hey guys. If I disconnect this wire here, and I add this extra wire, and then I put this here, okay, you see I've got that extra wire in. These bulbs, they're still fairly bright. I know you can't directly compare it with that last one, but you can probably go back a few frames and check that out. But if I do come back over here and I look, we see that the compass is actually still deflected the same amount, that same almost 20 degrees. So adding that wire in series didn't really do anything before and after. Okay, circuit C before we add this wire is actually the same as circuit A. So you can go ahead and just sort of do that, right? Because circuit C before I add that wire in parallel with that bulb is actually just the same circuit that circuit A was. So, yeah. Okay, but then I guess you can actually see it from here, so we'll keep this. Okay, if I take this wire and I hook it on either end of that second long bulb, this one right here, I'll go ahead and add that wire in parallel with that bulb. You see it immediately went out and this other one got brighter, right? So we'll take a look at that again. Okay, here I've got both bulbs the same brightness, the same amount of charge flow through them, and that 20 degrees of compass deflection that we saw before. And then I add this one, we see the first bulb get brighter and the second bulb go out. Okay, and if I look at this compass, that was weird. I just saw it move extra. Okay, well, that's fine. I'm okay with that. Okay. Oh, weird. Whoa. Y'all, that's really cool. Okay, I'm sorry. It looks like it's a little bit more than 20 now. But it also looks like if I bring my phone closer that my phone has a magnetic field, which is really neat. Okay, but yeah, anyway, yeah, it looks like it's a little bit more than 20 degrees now. Yeah, it looks like a little bit more than 20 degrees. So we did see an increase in charge flow or a decrease in overall resistance when we did that. And we definitely know that this bulb right here, there's not any charge flowing through it. Instead, it's choosing to flow through this black wire because that black wire has less resistance, and so it's not blocking that charge from moving through. Okay, go ahead then and finish off these questions here. Okay, I think I just talked about quite a bit of that, so go ahead and finish off those questions, go into the notes, fill those out. There's some extra notes today, just a nice little table that's side by side so that you can use that side-by-side table to be able to compare what happens when you add the bulbs in different configurations. So if you do have any questions on any of that, feel free to join me in my office hours from 2 to 3 p.m. each day via Google Meet. I think that's it. Please turn this in. Have a good weekend.